Okay, welcome back. Today we're going to begin Chapter 8, which is the beginning of our third unit. Your third test will cover Chapters 8 and 9, the sections that we do out of those two chapters. So this section, 8.1, begins us on solving and proving trigonometric identities. So on this very first page, these are your fundamental identities, which you do need to know. Okay, you should know these as well as you know your name in order to help you solve the problems coming up. So we've already done a lot of these. You already know a lot of these, but these need to be kind of in the back of your head because as you see these problems coming up, if you can recognize these identities, that's going to help you out a lot. So we have the reciprocal identities, which we already know which trig functions are reciprocals to the other. So keep in mind that when you have the reciprocal identities, I know that the sine of x and 1 over the cosecant of x are reciprocals. So that means if you have a sine of x times the cosecant, since those are reciprocals, then that would also equal 1. Right? So you can manipulate these to your advantage to help you simplify the problems coming up. Okay, so again, in this problem, if I multiply the cosecant over here, I end up with the sine of x times the cosecant of x equals 1. So that's also a reciprocal identity. Okay, so you can again manipulate these things. Same thing with the quotient identities, again, a lot of what we're going to do today, you want to put things in terms of sine and cosine. So we just need to remember that the tangent is the sine over the cosine and the cotangent is cosine over sine. That's going to help us sometimes to simplify. Your Pythagorean identities, that's a big one for being able to manipulate those and move things around. Okay, so we kind of already talked about this in one of the sections in Chapter 7. However, I want to remind you, we know that the sine squared plus cosine squared equals 1. That's based on your unit circle and the Pythagorean theorem. But you can move things over the equal sign just like a regular equation. So I could subtract the cosine squared over to the right, and I would end up with the sine squared of x equals 1 minus cosine squared. That's the same identity. It's just written in a different way. Okay, I could also start with the top, and I could decide, well, maybe I want to move the sine squared over to the other side. So I could do cosine squared equals 1 minus sine squared. Okay, all three of those are exactly the same identity. So you need to kind of be able to see, again, in your head when you have what. Now, if you have 1 plus cosine squared, obviously that's not an identity because that you wouldn't be able to manipulate this problem to look like that. Okay, so the same thing here. I could decide maybe tangent squared plus 1 is not what I'm seeing. I know that the tangent squared plus 1 equals secant squared, but maybe I see secant squared x minus 1. Well, if I move the 1 over there, I would subtract it, so then I would know that the secant squared minus 1 would equal the tangent squared. So keep these in mind that there's more than one way that they're going to look to you. Okay? It's real important that you know them. And then we have the odd and even identities. All I'm going to tell you about this, don't make these any harder than they are. The only even identities you have in trig are cosine and its reciprocal of secant. So when the argument, the thing inside the parentheses, is negative for these two, you can drop the negative sign and just treat it as a regular positive number. The other four, sine and cosecant and tangent and cotangent, because they are odd, then the negative sign in the argument has to come out front of the trig identity. Okay, so remember that the odd ones take the negative sign out front, and then the even identities you can drop, and there's only 2 of those. Okay, so that's how those work. So we'll do a couple of those so you'll see. So all that has to do with is whether or not you're going to drop the negative sign or you're going to move it out front. Okay, so not a whole lot happens with those other than that. All right, so there's 2 things you're going to do today. So if you look up at the top, we're going to simplify and then we're going to verify. They're almost the same thing, and we'll see that when we get to them. You're going to be doing the same thing to do both, But simplifying is one thing and verifying is another type of these types of problems, okay? So we're going to start with simplifying. And when you simplify, you're supposed to write your answer as usually one term and no fractions in it. Sometimes you'll get two terms, but very seldomly, usually these that you're given will break down to a one-term answer. All right, so let's go look at and be very careful whether or not these are being multiplied or whether they're being added. Okay, it's a big difference. All right, so the first one is cosecant x times cosine squared x times the secant x. And remember in trig, they put the squared next to the word, but remember that the cosine squared of x means cosine x times cosine x. Okay, it's just a shortcut way to write this. So this just means that we have two cosine x's in this problem, a cosine x times another cosine x, which is cosine squared. Okay, so just keep that in mind as you're looking through these. So the very first thing I would tell you when you're solving or simplifying an expression is to, if you can, if it helps you, change everything to sines and cosines, because then you can see what cancels out a little bit easier. So I'm going to rewrite the cosecant of x as 1 over the sine of x. Okay, same thing. Cosine squared is just like it is, cosine squared, which remembers over 1. And then the secant of x is 1 over the cosine. Okay, so now I can cancel one of the cosines in the numerator with this cosine here. So if I cancel that cosine with one of those, now in the numerator I'm left with just a cosine of x, and in the denominator I'm just left with the sine of x. And now I'm not supposed to write my answer with a fraction, so I need to switch this to what it is, which is the quotient identity. Cosine over sine is the cotangent of x. So that's the simplified version of what they gave me. Okay? All right, look at the next one. I'm going to change cotangent to terms of sine and cosine. So I'm going to have the cosine of x in the top over the sine of x times the cosine of x over the sine of x. Oops, over the sine of x. Okay, so again, cotangent is cosine over sine. All right, so remember that the sine of x is over 1, so the sines of x's will cancel. So now we're left with the cosine of x over the cosine of x. All right, cosine in the top and the cosine in the bottom, and that obviously reduces down to the number 1. So that's the simplified version of that. Okay? All right. Next page is more simplifying. All of these are a little different, so you just have to work with them. Do your best as you go through. All right, so for cosine theta times cosecant, that would be the cosine over 1 times cosecant, which is 1 over the sine. Nothing cancels, so you can combine that to the cosine of theta over the sine of theta. That can reduce down to the one term of cotangent. Okay? All right, the next one over on the right, cotangent is cosine over sine. And then the sine of x is just sine over 1. So in this one, your sines are going to cancel, and you're just left with the cosine of x over 1, which is just the cosine of x. Okay, so these are the easy ones. We're kind of starting off slow. All right. Now we have sine squared over cosine squared. All right, so since whenever I see squares in the problems, a lot of times that means I'm probably going to be looking at one of the Pythagorean identities. Not always. I did on the first one, that wasn't true. But when I see that, I kind of want to keep it in mind as I'm trying to simplify. So, and I also see that these are reciprocals over here. So that's how I know, that's kind of what I'm leaning towards, because this is going to be a square term and this is going to be 1 over here. And that's kind of a clue for the Pythagorean identities. So sine over cosine, remember, is tangent. So I'm going to change that to tangent squared. Okay, sines over cosines. As long as it's the same power, you can do that. Then sine times cosecant, those are reciprocals, right? Cosecant is 1 over sine. So remember, if you see the reciprocals being multiplied, that reduces to 1. And then that is a Pythagorean identity. You don't have to move anything around. Tangent squared plus 1 is secant squared. So that's what I have here. So remember, I'm trying to get this down to one term. So not a whole lot to be done here. It's easy as long as I know these identities. Okay? I have to be able to spot them in the problem. All right, so just like here, I've got secant squared minus 1. That is a Pythagorean identity, so I want to use that right now. So secant squared minus 1 is not listed here, but remember what I told you. I could subtract the 1 over. So if I did that, I would also get tangent squared of x equals secant squared minus 1. So that is an identity, and it's equal to tangent squared. So I'm going to switch secant squared minus 1 to tangent squared. Okay. Now, since I have cosines, I'm going to switch this to sines and cosines because I know that's going to cancel. I know that because in tangent, the cosine is in the denominator. So change your tangent squared to sine over cosine. Cosines are going to cancel, and you're left with the sine squared over 1. So we can reduce that down to just sine squared. Okay? So again, there's more than one way to look at this. Some of you might, if I wasn't doing this with you, you might have distributed. You might have done cosine squared times secant squared, which that would be 1. And then cosine squared times 1, which is that minus cosine squared. Then you could have gotten that to equal sine squared by that Pythagorean identity. So there's always more than one way to solve these. So, I'm picking the way that my brain is seeing it first and foremost, but that doesn't mean it's the only way. As long as every step you do is correct, you will eventually get to the right answer. So that's the nice thing about this is you just start on it. Do what you think you want to do, and it will work out as long as every step is correct as far as using your identities. Okay? All right. Down at the bottom, we have secant squared over tangent squared. So I don't want this fraction, so I'm going to look at what these are in terms of sines and cosines, so I can probably cancel something. So secant squared is 1 over the cosine squared, and tangent squared is sine squared over cosine squared. Okay, and I'm going to leave that minus 1 just the way it is. So now when I'm dividing fractions, remember you flip and multiply by the reciprocal. So I'm going to do 1 over the cosine squared times, and then I'm going to flip this. So that would be cosine squared over sine squared. Still got that minus 1 out there. So now I see that the cosines will cancel. So I'm left with 1 over sine squared minus 1. So again, I've got squares in this problem, so these are Pythagorean identities. So 1 over the sine squared, its reciprocal is cosecant squared. Sorry about that. Cosecant squared minus 1. Right? 1 over sine is cosecant. So look at your Pythagorean identities. Cosecant minus 1. Well, that's right here. Right? If I subtract the 1 over, I would get that the cotangent squared equals the cosecant squared minus 1. So that is an identity. That equals cotangent squared. Okay. All right. Last one of these, and then we're going to start verifying. So on this one involves a little bit of factoring. Okay, because I see each term in the top has a cosine in it. Each term in the bottom has a cosine in it. So I'm going to start by factoring out a cosine of x. So that's going to leave me cosecant squared x in the first term, and if I factor out the cosine of the second term, that leaves me 1. In the bottom, I'm going to factor out the cosine of x. That's going to leave me cosecant x. I'm having a hard time writing cosecant today. Cosecant x, and then if I factor out the cosine of the last term, I get plus 1. All right, so these are going to go away. They're going to cancel. Now I'm left with cosecant x squared minus 1 over cosecant x plus 1. Now I got to factor the top. This is a difference of squares. This is like, think about x squared minus 4. Remember, you can factor, take the square root of both. One's plus, one minus. So this would factor x plus 2, x minus 2. So same thing here. You can do the same thing with trig functions. This will factor cosecant x plus 1, cosecant x minus 1. So that's what I want to factor it. Cosecant of x plus 1, cosecant of x minus 1 over cosecant of x plus 1. So now the cosecant of x plus 1s will cancel out. So here's a problem where we didn't get down to just one term. There's nothing I can do with just cosecant and a minus 1. That's not a square. That's not a Pythagorean identity. So like I said, every now and then you might get one that ends up being two terms, but they're the simplest of terms that you can get. Okay? All right, so that's simplifying. And we're going to use everything we just did to do the verifying that's coming up next. So keep out and keep handy your identities because we're still going to be using those. But let's look at guidelines for verifying. Okay, so this is on verifying. So we have to do a proof. We have to prove that these things are equal. All right, so these are all of the things you can do in order to help you solve a problem. So again, it's kind of the way you see it and start it. So just because I'm going to do it one way might not be the way that you see yours. So when you guys are working your homework, you know, when you get to a problem and you need help or you're not finding the answer, you need to send me the work that you did so I can kind of see, you know, your thought process when you do these. Okay? All right. So you got to have all the basic identities memorized. That's a given before you can do well on this. Now, the big thing is that you have to work with one side of the equation only. So when you do a proof, verifying, you can't work with both sides. So I always say choose the more complicated side and then try to get it to look like the simpler side. All right, so same thing we've been doing. Look for opportunities to apply your fundamental identities. Change everything. If you have quotients, right, consider the reciprocals, change them to sines and cosines like we were doing. If you see a square term, think about your Pythagorean identities. If you have a negative argument, then you're going to change it up by using your even and odd properties. Basic algebra techniques, factor, multiply, combine like terms, get a common denominator. All the things that you've done your whole life with math, we're going to continue to do. Consider writing the expression in terms of sine and cosine. Okay? That's always a good thing to do, kind of get you started. If nothing else fails, do that. And the last thing, if nothing fails, if nothing comes to mind at all, just start somewhere and you'll see it work out. So step number 5 is always good if you have no other, you know, thought in your mind of what to do. Always change things to sine and cosines as a last resort because sometimes you'll kind of see what's going together. Okay, so we've got a couple pages of some proofs, right? So when it says verify, you're going to see an equal sign. If you look at your last 2 pages of notes, there were no equal signs. We just had one expression and we were simplifying it. Now we have to prove that the left side equals the right side. So again, you have to only work with one side. You are not allowed to work with both sides. So pick the side that looks the most complicated because it's always easier to take something complicated and reduce it like we've been doing on the last couple pages. It's really hard to take something simple and make it bigger, okay? So I'm obviously going to look at the left side, and I'm going to try to get the left side to equal what's on the right side. All right, so now I'm going to do my even and odd identities. Cosine and secant are both even identities, so I can drop those negative signs. So that means that cosine of x and the secant of x equal the same thing as that. Now your tangent and cosecant are odd properties, so that means the negative sign comes out front for tangent, and the negative sign comes out front for cosecant. Now, you notice in these problems that they put the variable, the argument in parentheses. If you're putting this on your computer or on a calculator, they have to be in parentheses. But on paper, you notice I didn't put them in parentheses. They're not in parentheses here. So, you know, that's the same thing as that, right? Cosecant x. So that's the correct way to do it. But shortcut, usually on paper, we don't have to do that. So just keep that in mind when you see parentheses around x or theta. You know, for me, that's okay. But when you're typing in answers, it has to be that way, okay? All right, so cosine times secant is done, and then I've got a negative times a negative. So this side is going to end up being a positive as well, right? So let me do that. I'm going to get rid of my parentheses now just to save some time. So we've got negative times a negative, so that's going to be plus tangent x cosecant x. All right, so now cosine and secant are reciprocals, so this is going to be 1 plus, these are not reciprocals, but if I change them to sines and cosines, I'll be able to see what cancels better. So tangent is sine over cosine, and cosecant is 1 over the sine. So I will see now that the sines cancel out, and I'm left with 1 plus 1 over cosine of x. And I know that 1 over the cosine of x is secant. And keep in mind, look at what I was trying to get to. I'm trying to get to secant x plus 1. So I'm almost there. 1 over the cosine is secant. So that's 1 plus the secant of x, which is what I was trying to prove. So usually once I get to what I'm trying to prove, I'll put a check mark. So that means I got that proof right. Okay? All right, example 3. Okay. Obviously the left side's harder, so I'm going to go work with that. So the first thing I'm going to do is multiply the sine through. Get rid of these parentheses. So sine times cotangent, and then sine times tangent. So I'm distributing just like I would if they were numbers. All right. Now I'm going to write things as sines and cosines so I can see what I got. So sine times cotangent. Cotangent is cosine over sine. And remember that the sine is over 1, if that helps you. Plus sine, which is over 1, and tangent is sine over cosine. All right, so here I have the sines canceling out and leaving me with just the cosine over 1. And over here I have sine squared, sine times sine in the top is sine squared over cosine. All right, so now I got to get a common denominator. Okay, this is over 1, and I am adding, so I need a common denominator. We haven't done one of those yet. So the common denominator would be cosine. So I'm going to multiply the top and the bottom of this fraction by cosine. Okay, so that gives me cosine times cosine in the top, which is cosine squared, plus the sine squared, this one over here, because now my denominators are the same. This is cosine and this is cosine. So that's all over the cosine of theta. Now I have cosine squared plus sine squared, which is the first Pythagorean identity, which equals 1. So 1 over the cosine theta, which happens to be the secant of theta. That's the reciprocal, and that's what I was trying to prove. So that's that proof. Okay? All right, moving on. Next one, example 4. Sine x minus cosine squared sine x equals sine cubed. So this looks harder, so I'm going to do the left, and I'm going to factor out a sine. So if I factor out the sine of x from each term, if I factor out the sine from here, I'm left with 1. And if I factor out the sine here, I'm left with cosine squared. That's a Pythagorean identity. 1 minus the cosine squared. I did that. 1 minus the cosine squared, right? When you move the cosine over, is equal to the sine squared. So I'm going to replace 1 minus cosine squared with sine squared. And now I have the sine times sine squared, which is the sine cubed. And that's exactly what I was trying to get. Some of them don't take long at all, so it just kind of depends. All right, example 5. This looks harder, so I'm going to do that. I got 3 things being added together, so I got a lot of squares, so I'm thinking Pythagorean identities, and so I want to kind of mix things up. I'm allowed to move things. So I'm going to write this as sine squared theta plus cosine squared theta plus cotangent squared theta. So now that I see I have this together, that equals 1. That's a Pythagorean identity. So 1 plus cotangent squared, also a Pythagorean identity, which equals cosecant squared, which is what I was trying to get. Okay? So you can see it's very helpful to know these identities because in your head you're seeing kind of things as you go. All right, for example 6, I would say the left side's going to be a little harder. Be careful on this. So because I'm dividing by 2 terms, I've got to get a common denominator down here. So this one's going to take a few steps. So I'm going to leave the cosine alone for a minute up in the top. And the secant is 1 over the cosine. And the tangent is sine over cosine. So you can see you do have a common denominator here. So that will give you, leave the cosine in the top. And now in the bottom, since you have a common denominator, you can write 1 plus the sine of x together over the cosine of x. Okay? Now we're going to divide by multiplying by the reciprocal. So we're going to take this times the reciprocal of this. So the cosine of x times the reciprocal, cosine over 1 plus sine. Okay? So now I have cosine times cosine in the top, which is cosine squared over 1 plus sine of x. Okay? So I'm trying to get this, so I'm not there yet, but I do know that the cosine squared is a Pythagorean identity, which is 1 minus sine squared over 1 plus sine x. And now I can factor that. Again, when I see Pythagorean identities, I know I can factor when there's a minus in there, just like that x squared minus 4, right? So this factors 1 plus sine x, 1 minus sine x, over 1 plus sine x. So now I can cancel the 1 plus sine x's, and that's what I was trying to get to. That one was a little hard, give you that, but that was what I was trying to prove. So that took quite a few steps. And again, you guys might find it in less steps doing something different to begin with. What you can't do is write cosine over secant and then cosine over tangent. That doesn't work. It only works if one thing is in the denominator, but you can't split up 2 things in the bottom. Okay? All right, example 7. I'm going to do the right side on this one. Okay, I don't know if that would make it easier, but I'm thinking that the right side might be a little bit easier to try to get 2 terms down to 1 term. Okay. Actually, maybe I'm going to change my mind. I'm going to do this side because this is a Pythagorean identity and then I'll already have my 2 parts. So I'm going to do that the sine squared equals 1 minus cosine squared. So I'm going to substitute that in there. That way I can break it up into 2 things. So see, even I will change my mind sometimes when you look at it differently. Okay. So now I've got my 2 terms. So now I can divide cosine into both of these. So this is 1 over the cosine. And then cosine squared over cosine. You can do that when one thing is in the bottom. So this is a good example. Here you had the 1 term in the bottom, so you can split it up. Here you had the 1 term in the top. You cannot do that. Okay, that's a totally different rule. So you got to be careful with those. All right, so I think I'm pretty much done here. So 1 over cosine is secant. And then cosine squared over cosine, you can cancel one of those, so you're just left with 1 cosine. And that's all you needed. So that one ended up being easier on the left than I thought. So again, got to look at it sometimes. Okay. All right. I hope you're getting kind of the hang of this and learning these as we go. All right, so example 8, I definitely would say that the left side's harder, and secant squared minus 1 is your Pythagorean identity, which is equal to tangent squared. So I'm going to go ahead and do that over secant squared. All right, and now I'm going to write these in terms of sines and cosines because I'm trying to get sine. So tangent squared is sine squared over cosine squared. Secant is 1 over cosine squared. Flip it and multiply, so we're going to get sine squared over cosine squared times the reciprocal of the bottom, which would be cosine squared over 1. Cosines are going to cancel, and sine squared over 1 is what you're left with, which is just the sine squared, which is what we were trying to get. Okay. All right, example 9, even and odd, so let's get rid of these. Anytime I see these, all that means is just get rid of these negatives. So cosine is even, so I can drop that one, cosine of theta, secant of theta. Sine is an odd function, so the negative is going to come out front, so it's going to make that minus sine theta cosecant theta. All right, so secant is the reciprocal, but this is in the bottom, so be careful with that. Those do not cancel out. So you have the cosine of theta over 1 over cosine, right? So when you flip it and multiply, you're going to end up with 2 cosines in the numerator, so be careful with that. And then you have the sine of theta cosecant of theta, which those are reciprocals. That does equal 1. So when you flip this and multiply, you're going to multiply by cosine over 1, right? Write that out. So cosine of theta times the reciprocal of that is cosine over 1. This is equal to 1. The left over here gives you cosine squared. All right, so this one we got to be careful because cosine squared minus 1 is not quite an identity. Okay, so come back over here and let's look at it. 1 minus cosine squared is sine squared, but we don't have 1 minus cosine squared. We have positive cosine squared and a negative 1. So just like always, for us to get this, we could multiply everything by negative 1, okay? Or factor out a negative 1, however you want to look at it. So if I factor out a negative 1, that gives me a negative cosine squared and a positive 1. Negative cosine squared, that's negative, and a positive 1, right? I just wrote it in the opposite order. I put negative cosine squared first and then the plus 1. So that equals sine squared, but we have the negative 1 out front. So that's negative 1 times sine squared, because I always noticed, look at what you're trying to get, right? The negative sine squared, so that's why it's negative, because it was the opposite of what was there. So that was what we were trying to get. All right, last problem. This is another common denominator. So left side's obviously the worst. I need to get a common denominator, so I'm going to multiply top and bottom of this by 1 plus sine theta, and then I'm going to multiply this one by 1 minus sine theta. Okay, or remember the rule, you can do this times this times this, over this times this. Either way you want, however you add, you're still going to get the same thing. So we're going to do 1 times 1 plus sine of theta, which is 1 plus sine of theta, plus, and then we're going to do 1 times 1 minus sine of theta, which is just 1 minus sine of theta, over these two multiplied together. 1 minus sine times 1 plus sine. All right. Okay, so let's see what we got. I can cancel the signs in the numerator, and I've got a 1 plus 1, so the whole numerator is going to give me 2. In the bottom, I'm going to FOIL this out. First, outer, inner, last. Because remember, I'm trying to get one term here. So 1 times 1 is 1. The outer is positive sign, and the inner is negative sign, so that's going to cancel out. And then you have a negative sign times a positive sign, so that's minus sine squared. This is a Pythagorean identity. It's equal to cosine squared, so we have 2 over the cosine squared. And cosine is the reciprocal of secant. So since cosine's in the bottom, I can move it to the top, make that secant. And that's what I was trying to get. Okay, that's one of your reciprocal identities. Okay, so, nothing hugely new here. You already kind of knew all of the identities that we're using. We're just putting them to a different use. So the new part is doing your proofs and simplifying. And again, I will say this all throughout Trig. The more you practice, the more you do this, the easier this gets. Most students either will fly through this because it makes perfect sense because you know all of the identities. If you don't learn the identities, you will struggle, okay? And we've got many more sections to go with this, so please start learning them if you haven't already, okay? All right, so that does it for this section. So work on your homework. Let me know if you need any help, and work on them daily, okay? All right, see you back here next time.